People imagine the Earth stopping like a merry-go-round, slowing down. Everybody stumbles a little, grabs a railing, laughs about it. That's not what happens. If the Earth stopped spinning right now, instantly, you and everything else on the surface would keep moving at over 1,000 miles an hour. That's not a stumble, that's a launch. Let's actually work through this properly, step by step, because the real sequence of events is far stranger and honestly far more interesting than everyone falls down. Here's the thing you need to feel first, before any of the rest of this makes sense. Right now, this moment, you are moving. Fast. If you're anywhere near the equator, the Earth's rotation is carrying you around its axis at roughly 1,000 miles an hour. Same speed as the ground under your feet. Same speed as the air around you. Same speed as a bird flying past your window. You don't feel any of it because everything's moving together, in lockstep. The same way you don't feel the 600-mile-an-hour cruising speed of an airplane while you're sitting comfortably in your seat, sipping a drink, barely aware you're hurtling through the sky. There's a name for why this matters, and it's one of the oldest ideas in physics: inertia. Newton's first law: a body in motion stays in motion unless something acts to stop it. Your body doesn't know, doesn't care, has no mechanism to care that it's the Earth doing the moving. It only cares about speed and direction, full stop. So if you stop the ground instantly, if the planet itself just halts, your body has absolutely no reason to halt along with it. The ground isn't just where you happen to be standing, it's what's been carrying you this entire time at a speed you genuinely never had to think about, not once in your whole life. So let's walk through the actual mechanism of an instant stop, because this is where it gets genuinely violent. Everything not bolted directly into bedrock, people, cars, trees, buildings, oceans, the atmosphere itself, keeps its momentum and goes flying eastward relative to the now motionless ground beneath it. Buildings would shear straight off their foundations. Oceans, still carrying that same rotational speed, would slosh violently over entire continents in walls of water taller than anything ever recorded in human history. Not a wave, more like the whole ocean deciding to keep going, while the seafloor underneath it suddenly didn't. And here's the part people almost always forget: the atmosphere. Air isn't bolted to the ground either. It would keep moving too at that same blistering rotational speed, scouring across the surface as essentially permanent planet-wide hurricane-force winds, howling over everything, until friction against the newly still ground eventually, slowly, dragged it to a stop. Now notice something I've been doing this whole time. I keep saying instant stop, and that phrase is doing an enormous amount of work in this explanation, more than it deserves, honestly, because an instant stop isn't physically realistic. Nothing in this universe just switches off like a light. Whatever force could stop something as massive as the Earth from spinning would have to act over some amount of time, however short. So let's ask the more honest version of this question. What if the slowdown happened gradually, not in an instant, but over centuries? This version is quieter. No catastrophic flinging, no instant carnage, nobody launched off the surface like a bullet. But it might in its own way be worse, because it's a slower, deeper unraveling of things you've never had to think about. Here's the real mechanism at play. Earth's spin creates a slight bulge around the equator. You are, right now, actually a little farther from the planet's center, if you're standing near the equator, than you would be standing at one of the poles, purely because of rotation flinging mass outward ever so slightly over billions of years. It's subtle, but it's real, and it's measurable. Now slow the spin down, gradually, and that bulge starts to relax. The planet slowly rounds itself back toward a more perfect sphere. And when that happens, sea levels shift dramatically, flooding some regions, draining others, entirely independent of anything to do with climate change. Just pure geometry, quietly rearranging itself as the spin that built the bulge in the first place fades away. Then there's the deepest layer of this, the part where the honest uncertainty really lives. And I want to be careful here because this is exactly where it's easy to overstate what we actually know. A slowly stopping Earth would gradually lose the day-night cycle you built your entire life around. One side would end up locked in perpetual daylight for longer and longer stretches, the other in longer and longer darkness as the slowdown progressed. And if it ever fully stopped, you'd be looking at questions about tidal locking, about whether the planet eventually settles into a fixed orientation relative to the sun, the way our moon has settled into one relative to us. And there's Earth's magnetic field. That field isn't some fixed property of the planet. It's actively generated right now by the churning motion of molten iron in Earth's outer core, a process called the Geodynamo. And that churning depends heavily on the planet's rotation to keep its structure and pattern. Slow the spin down enough, and that internal churning changes, and the magnetic field weakens. What exactly that does to our protection from solar radiation, over what specific time scale, interacting with a climate and a geology that would themselves be shifting at the same time, that's a genuinely complex, still actively modeled question. It is not a settled one. We can describe the mechanism cleanly. Spin builds the bulge. Spin drives the internal dynamo that builds the magnetic field. What we can't fully predict is the precise cascade of consequences that follows, because so many of Earth's systems are quietly, invisibly leaning on that rotation in ways scientists are still actively mapping out, piece by piece. So here's what actually gets me about this whole question, once you've walked all the way through it. We don't think about the spinning, ever. It's not part of your daily experience. It's not part of how the ground feels under your feet, not part of how gravity feels pulling you down, not part of anything you'd notice on an ordinary day. And yet almost everything about this planet, its shape, its weather patterns, the magnetic field standing between you and the raw radiation of the sun, even the simple, basic length of a day, every single bit of that is a direct consequence of something happening constantly, silently, underneath you, that you will never once feel directly, not for 1 second of your entire life. Here's the deeper idea hiding inside this thought experiment, and I think it's worth sitting with. Stability, it turns out, isn't the absence of motion. It's motion so consistent, so unbroken, sustained for so unbelievably long that it stops looking like motion at all and starts looking like simply how things are. You don't experience the spin as spinning. You experience it as stillness, as solid ground, as the ordinary backdrop of being alive. But it was never actually still. It just never stopped long enough or briefly enough for you to notice the difference. The Earth has been spinning without pause for over 4.5 billion years. Not because anything is holding it to that promise. There's no law of the universe that says it has to keep going. No guarantee written down anywhere. It's simply obeying the same basic rule that would send your body flying off its surface in an instant if the spinning ever did stop. Nothing changes velocity without a reason, without some force acting on it. And so far, across 4.5 billion years, nothing has given it one. Every sunrise you've ever watched, every ocean current that's ever shaped a coastline, every direction a compass needle has ever pointed reliably toward a magnetic north that's only there because something deep below your feet keeps stirring, keeps churning, keeps turning. All of it quietly has been riding on that one unbroken motion the entire time. A motion you've never felt, never noticed, and never had a single reason to doubt. Right up until you actually stop and ask what happens if it ever stopped at all.